Good morning students. Today we will discuss about the chapter called motion. This includes the class 9 syllabus, one of the chapter in physics. In physics there are 5 branches mainly, that is one is mechanics, number 2 it is waves and thermodynamics, and number 3 electricity and magnetism, number 4 optics, and number 5 it is modern physics. Motion comes under mechanics. The main objective of mechanics is to study the properties of the particles which are in the rest or which are in the motion. Firstly comes to the what is meant by rest. Rest means that whenever the particle doesn't change its position with respect to the time, that means that as the time increases, if the particle does not change its position, then we can say that the particle is at rest. Suppose if an object is placed on a table, if we didn't apply any force or if we didn't pull or push the object, then the object will stay as long as we apply the force. So this is an example for the particle or object is at rest. Now comes to the motion. Whenever the particle changes its position with respect to the time, can be called as motion. That means as time increases, if the particle position changes, either increases or decreases, then we can say that particle is in motion. The example it is, if a person is walking on the road, as the time increases, the person changes its position, or daily we will see that it is a fan is moving. Suppose whenever the fan is moving, then we can say that fan is in motion. So this is the example of rest and motion. Now let us consider an example that if a train is moving, in that we are having the passengers. Let us consider 2 passengers which are in the same compartment. Now with respect to the co-passenger, the other passenger will be at rest. But whereas if an observer is observing outside the train, then that observer which is at outside, he thinks that both the passengers and the train are moving. So with respect to the point of reference from where we are observing, we can say that particle is at rest or at motion. That means here rest and motion are both relative terms. Now in mechanics we will have it is broadly classified into 2 types. One is kinematics and another one is dynamics. Kinematics deals with the properties of particles whenever the particles are at rest. That is, we can call it kinematics can also be called as statics. That means here we will study the properties of particles whenever the particles are at rest, or we can say that whenever particle is in motion, we will study the properties of the particles irrespective of what is the force applied on it. Suppose let us take an example. Whenever the fan is moving, we will try to find the speed of the fan or what is the distance moved by the fan, but we don't consider how much force is applied on the fan. So this comes under kinematics or so called statics. Now next comes under dynamics. Dynamics deals with the properties of the particles whenever a force is applied. Say for example, the best example or one of the example, it is the motion of the rocket. Whenever a force is acted on the rocket, how much or what are the properties of the rocket? That is number 1. And number 2, or else the motion of the particle in presence of any field, or if the motion of a person which is moving under the influence of any chemical force or magnetic force or any type of force can be considered as an the dynamics, okay, or else motion in a lift. Okay, now here motion in our syllabus, the motion contains the kinematics part. Okay, that is whenever the particle is in motion, then we need to study the properties of the particle like distance covered, speed, okay, and thereafter we will find the other properties like velocity and acceleration. Okay, fine. Now firstly comes to the kinematics. Okay, as we discussed firstly about the rest and motion. Okay, and then next comes to, that means whenever the particle is in motion, the particle can travel in any dimension, that is either one dimension or two dimension or three dimension. Okay, here we will say the dimension with respect to the Cartesian coordinate system, that is x, y, z. Okay, suppose if the particle is moving along only one axis, that is parallel to x axis or parallel to y axis or parallel to z axis, then we can say that the particle is in motion in one dimension. Whenever the particle is traveling in two dimensions, either x axis and y axis, that is xy plane or yz plane or zx plane, then we can say that the motion of the particle in two dimensions. And similarly, if the particle is in motion along xy z plane, then we can say that the particle is in motion in three dimensions. Okay, now comes to the motion in one dimension. Motion in one dimension means, suppose if a person is walking on a road, that means the person is walking on a straight line. So we can consider that the motion of the person as in one dimension. And comes to the example of motion in two dimension, that is whenever a particle is moving in a circular path, then at any point of time we will have both x coordinate and y coordinate. So we can consider the motion of a particle which is moving in a circular path can be considered as a two dimension. And similarly three dimension means, suppose if a kite is flying, that means kite is flying in space or in the sky. So at any point we will have the three dimensions, that is x coordinate, y coordinate and z coordinate. So like this we can have the motion of the particle in either in one dimension, two dimension or three dimension. Okay, now comes to the distance. Firstly, here in my lecture we will discuss about the distance and thereafter examples of displacement and introduce the quantities like speed, velocity, acceleration, and thereby we will have the types of motion like uniform motion and non-uniform motion. Okay, firstly we will see the distance. Suppose, before going to the definition, see the distance explains the actual path between the initial point and final point. Okay, here the initial point, it is that from where the particle is being started is called initial point, and final point where the particle is going to stop or up to which point the particle is willing to move is called final point. Say for example, if I want to find the distance between any two places, suppose let us take place A and place B, the actual path length between A and B is called as, actual path length means it is the length between the 2 points. In mathematics we will do this distance by using the formula under root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so that means the same formula here also we will apply. Distance is equal to under root of x2 minus x1 whole square and y2 minus y1 whole square, where x1 comma y1 are the initial coordinates, or we can consider it as an initial position. Okay, now x2 comma y2 are the final position, that is final x coordinate and y coordinate of the particle. Okay. Now comes to the, that is distance traveled. It is actual path traveled or traversed by the particle. Suppose if a person travels 5 meters towards east and 3 meters towards north, then the total distance will be 8 meters. Like this we will find the distance. Suppose if a particle is moving in a circular path, the distance covered by the particle is equal to the circumference of the circle. It is, which is equal to 2 pi r, where r is the radius of the circle. So distance covered by the particle is equal to 2 pi r. So like this we will have the different cases or different situations. Okay. Suppose in the form of a square, if the distance covered by the square, that is in each side, let us consider in a square each side are equal and side of the square equal to 1 meter. Along the two sides, suppose if we consider the square ABCD, along the two sides, that is AB and BC, the distance traveled will be 2 meters. In the same example, if we consider the square ABCDA, the total distance covered, it is 4 meters. Okay. So like this we will have the different examples. In all the examples, the common point it is that the distance covered is equal to the actual path length between 2 points. Here in square or circle, I am finding from initial point to the final point. That's why in the definition it is actual path length between initial point and final point. Now next comes to the displacement. Now see, before going to displacement, since it is the actual path length, so SI unit of distance is meters and CJ's unit of distance, it is centimeters. As we know, 1 meter equal to 100 centimeters. Okay, 1 meter equal to 100 centimeters. Okay. Now comes to the displacement. Displacement is the shortest distance traveled by the particle from initial point to the final point. Okay. If you see the definitions of distance and displacement, the difference it is that distance is the actual path length traveled by the particle from initial point to the final point, and whereas displacement it is shortest distance traveled by the particle from initial point to the final point is called as displacement. Here the term called shortest distance, that means here instead of having the suppose if we consider an example of the square ABCD of each side 1 meter, the distance traveled along AC, that is AB plus BC, is equal to 2 meters, whereas the displacement, that is the shortest distance, that is here my initial point is A and final point is C. So from initial point to final point, the shortest distance can be obtained by drawing a diagonal, that is it comes into the, in the square we will have an right angle triangle, that is ABC, that is according to the Pythagoras theorem we will have AC square equal to AB square plus BC square, that is nothing but AC is equal to under root 2 meters. So root 2 it is 1.414 meters, distance is 2 meters and displacement will be 1.414 meter. So often 1.414 is less than 2. So that's why displacement is shortest distance traveled by the particle from initial point to the final point. Okay. So even here also in the circle, let us take the second example as circle. In the circle, what will happens if a particle is completes one rotation, that means a particle is rotating in a circular path of radius r. After some time, that is after let us consider after 10 seconds, again the particle reaches the same initial point. That means that we can say the particle completes one rotation. So at this point of time we can say that initial point and final point are same. So whenever initial point and final point are same, we can say that it is particle completes one rotation. So whenever particle completes one rotation, now I want to find the distance covered by the particle. So distance covered by the particle is equal to circumference of the circle, that is nothing but 2 pi r, where r is the radius of the circle. Since displacement, since initial point and final point are same, so the displacement of the particle will be 0. The displacement of the particle will be 0. Okay. Now how we can say that the displacement is 0? Means in general the displacement can be found by using the formula, that is the change in displacement or change in the position. So that is the change in displacement equal to change in position. Change in position means nothing but final position minus initial position. Since here final position and initial position both are the same, so that's why the displacement will be 0. Okay. Suppose let us take an example. Suppose if a bus is moving from place A to place B, after some time again the same bus is traveling from place B to place A. That means after a time of say suppose 2 hours, the bus is returning to the same initial point. So at that point initial point and final point is same. So in this case I can say that displacement of the bus is 0, but the total distance, it is distance travelled from A to B plus distance travelled from B to A. So total distance means it is distance travelled from A to B and distance travelled from B to A, whereas displacement will be 0. Okay. One of the main property of displacement is if initial point is equal to the final point, then we can say that displacement is 0. The same principle we are applying in the circle. Now comes to the semicircle. Semicircle is defined as the area of a semicircle is equal to half of the area of the circle. So that means here also we are having a radius r. Let us consider a particle is moving in a semicircle such that I want to find distance and displacement. Now distance covered by the particle which is moving in a semicircular path, distance covered is equal to, whenever the particle is moving in a circular path, distance covered is equal to 2 pi r. If the particle is traveling in a semicircular path or in a semicircle, then distance covered is equal to half of the, that is 1 by 2 times circumference of a circle, that is 1 by 2 into 2 pi r. So it will gives the pi r. So distance travelled by the particle in a semicircle is equal to pi r. Now displacement of a particle whenever the particle is moving in a semicircle, that means here the shortest distance, instead of traveling the particle along the semicircle, we can have the shortest distance from one of the end point of the circle to the center, and again center to the another end point. So from one end point to the center it is equal to the radius, and similarly from center to the other end point is equal to the radius. So the total displacement of a particle in semicircle is equal to twice the radius, that is nothing but 2r. So the distance travelled in a semicircle is pi r, displacement of a particle in a semicircle is 2r. Whereas like this, that means we have discussed till now it is about square, circle and semicircle. Like this we will have the different situations. Say for example, if we consider the geographical directions like east, north, west, east and south, Okay, suppose if a person walks towards east 3 meters and after some time he returns and he walks towards north 4 meters. Okay, now I want to find the what is the distance traveled by the person and what is the displacement traveled by the person. Distance traveled, it is 3 meters towards east and after some time he returned and then he traveled a distance of 4 meters. So the total distance it is 3 plus 4, that is nothing but 7 meters. Now the displacement, since it is from east to north, so from east to north the shortest distance can be obtained by drawing the diagonal from east to north. So that is, that distance can be obtained by using the Pythagoras theorem. If we consider the east point as A and the center at B and the north point as C, that is at B it is right angle and AC is the hypotenuse. So according to Pythagoras theorem, AC square equal to AB square plus BC square, that is nothing but AC square equal to 3 square plus 4 square. So AC square equal to 9 plus 16, that is nothing but 25. So AC equal to 5. So the displacement of the particle or displacement of the person, in this case it is 5 meters, whereas distance traveled by the person is 7 meters. So always, sometimes it will be displacement will be less than or equal to the distance. Sometimes displacement is equal to the distance. Okay, in which case we will observe. Suppose if a particle or if a person is moving in a straight line path, now suppose if I am traveling in a straight line path for 1 meter, okay, now the distance traveled by the person is 1 meter. Now the displacement, whenever the particle or person is moving in a straight line path, there will be no shortest distance other than that. So that's why distance is equal to displacement whenever particle is moving in a straight line. Whenever the particle is moving in a straight line, distance equal to displacement only in straight line. Suppose whenever the particle is moving other than in straight line, distance and displacement will differ. So that's why we will say always displacement is less than or equal to distance. Whenever it is in straight line motion or straight line path, in that case only displacement is equal to distance. Okay. Now we got some idea about what is meant by distance and what is meant by displacement. Now I will consider an xy plane with respect to origin. With respect to the origin, we are having let us consider 2 points, suppose A and B. Point A is at position x1 comma y1 and point B is at position x2 comma y2. Okay. Now I want to find the displacement with respect to the origin. Here origin is my fixed point. I want to find the displacement, that is AB. The displacement can be found by using mathematically under root of x2 minus x1 whole square plus y2 minus y1 whole square. The same thing here also we will find like that only. That is final position minus initial position, that is OB minus OA. Okay. In order to explain here, we need the direction of the particle. Suppose for distance we don't need any direction. What is the distance between the 2 points means simply we will say the values. Okay. But whereas for displacement we need to explain or we need to find the direction, in which direction we are measuring it. Okay. Now towards the north or towards the east, like that we will explain 5 meter towards north or 5 meters towards east or 8 meters towards south, like this we need to explain. So displacement is having a value as well as direction, So displacement is a physical quantity which is having a value and direction. So